Today we're going to talk about integration. And if you haven't seen the video on the introduction to calculus and integration, I'd suggest that you do that first. Integration is also known as antidifferentiation. And therefore, what we do is the exact opposite of when we differentiate. So let's have a quick look at differentiation. If I have a function, let's call it f of x, of 3x squared, then when I differentiate, I call that f dash of x. And I'll end up, remember, I multiply the coefficient by the old power and drop the power by 1. So I end up at 6x. Now, when I anti-differentiate, what I'll be doing is I'll be going this way. So what effectively I will do is I will raise the power up by 1, and then I'll divide by the new power. So in this case, I will start with 6x, and I'll end up upping the power by 1. So my power, which was 1, will become squared. Then my coefficient stays the same, and I divide by the new power. And you can see, once I simplify this fraction down, I'm going to end up with 3x squared, which is where I started. So then my first rule of antidifferentiation when I'm integrating or anti-differentiating a polynomial is that if I start off with a function where I have a x to the n, and this is the sign I use to take the integral, and I do that with respect to x, so this dx is always going to be there, then remember, I lift the power by 1, so I'm going to have a power of n plus 1. I'm still going to have my coefficient, and I divide by the new power. And this is where we're going to start. But there's a small trick, or maybe a little problem. If I have a function y, or a relation y, of x squared, and I take my derivative, I end up with 2x. But if I have exactly the same, but a plus 3 here, and I take my derivative, I lose the information about this plus 3, or if it's minus 6, or plus root 7. It doesn't matter. If there's some sort of constant when I take the derivative, I end up with nothing here at all. So when I take my antiderivative and I move back this way, I need to remember that there is always a chance that I had a constant here. So therefore, when I take my antiderivative, I need to remember that there might be a constant. And I'll just write that as plus c. There are some questions in which this constant is really important, and we'll work out how to calculate what it is. There are other questions you'll see where actually the constant drops off the page. So in summary, the integral, which is this sign, of a polynomial, let's call it ax to the power of n with x, equals ax to an increased power over the new power plus some constant. Now it's worth keeping in mind as well that if I have a function f dash of x, if this is the derivative, then the antiderivative is f of x. But if I start off with f of x and I want to take the antiderivative of that, I can do that, and I call that capital F. So there's a couple of different ways to write it. And finally, just like when we take a derivative, if I have 2 or 3 polynomials, so I have, let's say, for example, a to the power of n plus b to the power of m, and so on. and I want to take the antiderivative of all of that with respect to x, I can take the antiderivative of the first term and the antiderivative of the second term, and so on. So I can take each of the terms separately. If you like this or any of my other videos, please subscribe to my channel or like the video. Thanks.